Welcome to a tutorial video on Phaser, the HTML5 game framework. This video is the start of a number of videos within a series going over how to create a basic platformer, how to move a sprite around, jumping mechanics, things like that. To start with though, I have part 1 here. We have a pretty basic HTML file going here. We basically have a title and we're including 2 script elements here. We're including the Phaser library and we're including a game file that's going to have all our game mechanics in it. So if you look over here on the left, you see our organization is that on the site root we have 2 folders. We have an assets folder that contains at the moment our character.png. This will be the sprite we're going to move around. And then we have a JS folder that contains our game JavaScript. It contains the Phaser library and it contains our game.js file. And of course, also in the site root is our index.html file that we're looking at currently. So for all of these videos, I'll be including a source code link. It'll be a bit.ly link that links directly to a zip file that has all of the code in one place, including the assets, so you can play with this code later. For this video, it's Phaser Friday 15_01, because this is the first video of a number of videos on creating a basic platformer that's part of a greater series called Phaser Friday. So of course the last thing within our HTML file here is a div element with the ID Phaser. Now that's going to be important in just a moment. So moving over our game.js file, we see the very first thing we're doing is creating a game object. Now within Phaser, the game object is basically the center of its whole universe. Everything that happens within a Phaser game happens from its game object. So the very first thing we do is create a new Phaser.game object, tell it what we want, and then everything else springs from that game object. So the arguments to the Phaser game object go like this. The first 2 are the width and the height of the game in pixels. So right here I'm using 500 by 500, which means it'll be a square. 500 pixel width and a 500 pixel height. The third parameter is the rendering system. How do we want it to render? If you use Phaser.auto, it will try to detect if WebGL is enabled in the browser you're using. If it isn't, it'll fall back to Phaser.canvas, the canvas rendering system. So you can use Phaser.canvas, Phaser.webgl, or Phaser.auto. Any of those are valid options. However, I recommend, unless you have a reason to choose a different one, to go ahead and use Phaser.auto so that Phaser will choose for you which one will be best. So the fourth parameter is actually the parent element of the game. Remember back in our index.html file we set an ID equals Phaser for the div element. This is where that comes in. This is the parent element of the game, so this is where the game canvas will be located within the index.html page. So the last parameter to a Phaser game object is actually what functions we want within our game object. Game objects are made up of a number of different functions to do different things. There's about 5 total, sometimes 6 depending on what you're doing. The main 3, however, are the preload function, the create function, and the update function. And they run in that order. The very first thing that happens in any game is the preload function. So it loads anything that needs loading before the game loads itself. The second one is the create function that creates any game objects that you will be using, initializes any of them to their values they need to be. And so the third thing here is the update. This is the game loop function. This is what will be called every game loop. So every time the screen refreshes, this is the update function acting. So in this example here, I've set out each associated function to be associated with a function of the same name. So the preload attribute of the game is set to a function called preload. The create attribute is set to the function create. And of course update to update. So the first thing that happens, I said, is that the function preload is run. So this is the function preload right here that I've got highlighted. The first thing we're doing is loading a sprite sheet, character.png. I mentioned that before. We have the character.png file within our assets folder. We also need to tell Phaser, since this is a sprite sheet, how big each frame within the sprite sheet is. So if you're not familiar, a sprite sheet actually is a sheet of sprites. That is, it is one image file containing multiple images or multiple cells within an animation for that image. It's an easy way to store multiple pictures within a single image. So in this case, like I mentioned at the very top, once we created our game object, we can keep using it to initialize more things and to load other additional resources. So within our preload function, we are using the game object, using its game.load function to then call game.load.spritesheet to load a sprite sheet. Notice the dot between each one of them. So the game object, its load functionality, and within the load functionality, its sprite sheet loading functionality. So the first thing we're feeding it within the game.load.spritesheet function is the name of the cache key we want. Instead of referring to everything as assets.character.png or some very long name to the URL of whatever the resource is, we can give it a key. That's what we're just going to call it. We're going to call it character. So when we reference it later, we just say, oh, that resource, we're calling it character. And of course, the second parameter here is the actual URL to the resource. So assets/character.png, as we showed within the assets folder in the character.png file. And the last two are the size of each frame. As I mentioned, since it's a sprite sheet, contains multiple pictures or multiple images within a single image file. So we want to tell Phaser, hey, each frame is 40 pixels by 64 pixels. And if we click on the character.png, we see its total dimensions is 80 by 64, meaning that each frame is 40 by 64. Now, after the preload function, we have several initialized variables here. Now, we're creating them here outside of any function so that they can be accessible to any function within all of these. So we want to create variables that are outside of create or outside of update, so both create and update can use them. So we're creating a variable to hold the player sprite, the player controlled sprite. We also want something to hold which way the sprite is facing. And then we have two more that are based on our physics. A horizontal move, and then some amount, and a vertical move. And of course, remember that within the coordinate system of most graphic systems, and especially one within browsers, a negative direction is either up or left. Positive directions are down and to the right. I always have to pause when I think about it myself. So horizontal is a positive movement if we're going right, and negative move if we're going left. So since this is a vertical move, it's negative going up. And the last thing we have here is initial value of our timer. The reason why we have that is that we want to actually be able to make sure the player only jumps through a certain amount of time. So they jump, a little timer goes, and then they can jump again. So they're not constantly bouncing up and down like a rabbit or if they were on a spring. There's just a little bit of timer there to make it slightly more realistic. So once we have a preload function done, we're going to look at the create function and the update function. So as I mentioned before, running in order, the preload function will get run one time, the create function will get run one time, and then the update function will actually keep on running over and over and over and over again for the entire life of our game. But let's take a second here to look at the create function. So again, we're using the game object we created at the very beginning, and we're setting the stage background color to gray. This actually should be gray right here, not white. So we're setting to D3, D3, D3. Now each game object has a stage object as part of it. And the stage is actually what we're adding things to. It's sort of what you can think about as the world of the game. Each game world has a stage, and we can change things to it. So the very first thing we're doing is changing the background color to gray. The next thing we're doing is starting the physics arcade system. Now Phaser comes with a number of different physics systems as of this recording. The easiest one to work with and the most useful one for just starting out is actually arcade physics. And what that does is give us things like velocity and speed without overly complicating it with variables we don't necessarily need when we're just moving things simply in one direction or another, or jumping. So Arcade is a great starting physics system. The thing we're doing after that is actually creating the player-controlled sprite. Using, just like we had game.load.spritesheet, we have game.add.sprite, named for each functionality with a period between them. So we're using the game object, we're adding a sprite, we're adding something, and then we're adding a sprite. And then it has 3 parameters itself. It has an X position, a Y position, and then the cache key of whatever resource we're using. So notice this is character, and this is character. So we're referencing the resource of the sprite sheet within the creation of our sprite here. So we're saying, hey, add a sprite, and when you add it, go and look at the cache key that matches this resource, and then use that. And the last thing we're doing is assigning that to player so we can keep track of it. We can just call game.add.sprite to add a sprite, but if we want to control it, we have to maintain a reference, and so we have the player variable. So we're creating a sprite at x, y, and using this resource, and we're assigning it to the variable player. So as this comment explains right here, by default, sprites do not have a physics body. That is, they don't have any physics functionality by default. Now the reason for this is actually to cut down on the number of calculations per update. If you're not using physics in your game, there's really no reason for all the sprites to have physics bodies. So in order to enable the physics body, we have to again use the game object, call physics, call enable function, and supply it with whatever we want to enable the physics on, in this case player. And we want the player to have a physics body because we want to do, down here, we want it to have gravity, and we also want to move it using its velocity, which requires it to have a physics body. So because we've enabled the arcade system, the arcade physics system, our player variable, which is a sprite, will have the physics arcade, will have a physics arcade body. And so the last two things we're doing within our create function is we're saying that we want the player's body, the physics of the player, to collide with the world bounds. So when the world is created within a phasor system, it is locked to its width and height in pixels. So it starts with 500 by 500. And we're saying by setting this attribute on the player body that we want it to collide with those world bounds. Don't exceed any of the edges of the world, basically, is what we're saying. The very last thing we're doing is we're actually setting some gravity. Now this is important because if we're jumping, we don't want to continually float off into the sky. We want enough gravity so that the player can sort of jump and come back down, jump and come back down. And so we're setting that right here. And we're setting gravity to y. Now if we set gravity.x, we can apply something like a wind effect in that the sprite will be moved either towards the left or towards the right, depending on if we set it to positive or negative. In this case, with a positive y, it means gravity is going to be pushing down on the sprite. So the sprite's going to continue to move down the screen. So our last function is the update function. So now that we have a player variable, it's a sprite, it has a physics body, we're colliding with the world bounds, and it has a gravity, we want to actually do some things with it at this point. So the very first thing within the update function is to actually reset the x velocity each cycle. So the reason for this is that we don't want the velocity to compound as the updates keep happening. We don't want it to get faster and faster and faster. We want it to move at a fixed rate. So we reset each update its velocity so it doesn't keep moving. Like the player isn't standing on ice and isn't slipping and sliding. They're moving or they're not moving. So each time, if nothing else happens, the velocity will be reset to 0, unless we're holding a key down. And that's the next thing we check. So we have two different checks here. We want to check if the left arrow key is being pressed, And then we check if the right arrow key is being pressed. And since we can't move both left and right at the same time, we're using else here. So if left is being pressed down, we're going to do some things. Else, if right is being pressed down, we will do some other things. So if the left arrow key is being pressed down, that is, if the game.input.keyboard is down is true for the phaser keyboard.left, then we want to do some things here. So the first thing we want to do is set the velocity.x to a negative horizontal move. Again, remembering that we're moving in a negative direction, therefore we're going left. And we set a horizontal move up here to be the amount we want to move horizontally each time. So we set it to a horizontal move, we're moving left with a velocity. And then we want to check, are we facing left? If we're not facing left, set it back to left. So if we were facing right when we got to this point and we pressed left, face left. If we were already facing left, well, don't change anything. Don't even worry about it. And it's the same for the right arrow key. Again, we have a positive velocity for x, therefore we're moving in a right direction, and then we're checking to see what direction we're facing. If we're not facing right, set it to right, because then we were facing left. If we were facing right already, there's no reason to even worry about it, so we won't check it. And so the last thing that's happening, or the second to last thing that's happening here, is we'll check the jump button. In this case, it's going to be spacebar. Jumping within the arcade physics gets a little bit complicated because instead of just moving a velocity x or velocity y, we want to be able to test a number of different things. Like we want to be able to press spacebar, but we also want to see if our body is on the floor. That is, if we're standing on something, because we don't want to double jump yet. So we just want to say if we're standing on something, we can jump. And we need to test if the jump timer has expired. So we have 3 different requirements for jumping. We're pressing the button, we're standing on something, and the amount of time that we tested for, which was set at the very top here, starts at 0 and will be moved by 350 milliseconds. So 3 different things here. So if the player is pressing down, the player is standing on something, and if at least 350 milliseconds has gone by, then the player is allowed to jump again. If all of those 3 things have happened, we do 2 different things. We set the velocity.y to the vertical move, which of course means we're going up, because remember vertical move was a negative number, so your vertical move is negative 120. So we're moving up. And then we're resetting the jump timer to the game.time.now, so whatever the exact time is according to the game, plus 650 milliseconds into the future. So the current game.time for each update has to be greater than the jump time. And every time it's jumped, the jump timer is set to the current time plus 650 milliseconds. The very last thing we're doing here is just checking to see if facing is left. If it is, remember, during all of these we were just checking facing. We weren't actually doing anything to the sprite itself or changing the cells, changing the frames. We were just checking strings, checking if facing was left or if facing was a string right. So the very last thing we do is actually change the player's frame. So the player.frame property of the sprite object is which frame within its sprite sheet, if it's associated with a sprite sheet, should be enabled at any one time. So if the variable facing is equal to the string left, then we want to set the player frame to 1. Else we're setting the player frame to 0. Now remember, looking at character.png, if we're facing right, it's actually 0. If we're facing left, it's 1. So if it's facing left, it's frame 1. For facing right, yes, if we're facing 1, we have, and then facing right is 0. So I've gone over all of this code, which is about 120 lines of code here. What does this even look like when we play it? Well, to test it using NetBeans here, I click on the browsers, and I'm going to use Chrome for these examples. I'm going to click on play. And as you just saw, we created a sprite. We associated it with the sprite sheet. We used one frame at a time, either frame 0 or frame 1. And then we used gravity. So I'll refresh it here so we can see that again. And gravity was invoked on it because it has a physics body. So the gravity was invoked, the sprite moved down, and then it collided with the world bound. So it can't go through the edge of our game here, and then stopped. So if I press right, the character looks right. If I press left, the character looks left. And if I press spacebar, we jump. And if I keep pressing spacebar, notice we can't jump in the air because we're not on the floor. We're not standing on something. Also, if I keep pressing spacebar, notice the jumps. We don't bounce up and down like on the spring. We jump, and then we float down, and then we jump, and we float down. That's the timer working. So we can move right, we can jump, collide with the world bounds, move left, and jump, collide with the world bounds, and move around. All within our 500 by 500 canvas, our world space. This is the world bounds at the moment. 500 pixels by 500 pixels. As we saw when we created it, we have 500 pixels by 500 pixels. And then if we press spacebar, we jump. If we press left, we move left. If we press right, we move right. All based on moving with velocity, which is based on the arcade physics as applied to a sprite within a phaser game object. And so there you have an overview of how to create the basics of a platformer using left and right and jumping, all colliding with the world bounds and using an applied, as I just mentioned, arcade physics system. Thanks for watching.